So during the week pass the stickers, I want to just briefly mention this one again. So this is our Piazza. So everyone can access this one. And if you click the Google Drive, we have all the materials here. So for this section, Program 5, so we already uploaded several material. So here, this is the slide what Olga presented this morning and now. And then this three, one is the material for today. We will go over this one. And then people who arrived late, please download this zip file and unzip and make available in your computer, and then we are gonna start to practice. And if you have any suggestion or comment, please put some note, Piazza, or at the end of the course, please write something in your comment and then just give it to me. So my case, I download the file and then unzip it and then just make available this file in my desktop. People already download the files, please put the blue one. If you have an issue, please put the red one. Okay, so I think I can start. So today, from now to at the end of today, you will work with me. It will be a long day. And then today we are only work for the MSstats. So the Olga introduced IPRG data, and then people already attend the previous class, maybe heard about the IPRG data set. But this section, we are going to work with the whole IPRG data. And then we use the 4 different processing tools: Skyline, MaxQuant, Progenesis, and OpenMS. And then we are gonna just keep practicing, and then we will more focus on what the details so we can adjust and so on. So before we start, I want to start, like Olga already explained the more detailed one, but I will more focus on the people who actually use this one, what we have to concern about it. So here's the workflow in MSstats, and then it will be very similar. So here we need to set up the experiment design, and then we need to do mass spec measured, and then we do some statistic, and then we need to interpret. The first step is what we briefly talk about, the normalization and so on. This is the most important part. So whenever you just finish everything and then just give me the data and then, oh, I want to do this, and then no, I cannot do this. You have to come here, come to me very at the end of your, very at the beginning of your research, and then you need to talk about it. Especially, some of the people are already aware about the blocking or replication and the randomization. However, especially this normalization is kind of the really big issues. Especially if you want to make the large scale of the experiment for biomarker study and so on. So the one of the example is they already have some experiment, one batch, and after 1 year they want to do something else, similar one, but they add more sample and they want to do something, and then they want to merge this data. How? This is most likely is impossible. This is really difficult. So for this cases, we already need to think about how we are going to normalize these 2 data sets. So I just ask, do you have any repeated measurement between two batch? Or do you have any repeat of the standard and so on? And this, you think about this kind of standard protein or peptide, you need to think about it. So this is the most important part. And then second one, if you already set up all the experiment and then you measured this, and then this is one of the figure from Skyline team, Skyline, the ecosystem. I think people who already take the Skyline team, probably you already saw this one. So this is what they think about it. So for example, here's the hypothesis. So here hypothesis is kind of what kind of protein you are interested in. However, for statistician, hypothesis is a different meaning. Like hypothesis is there any difference between two different groups and so on. So we use same terms but different purpose. And then they made a assay development and then acquisition and processing. So like whole scheme actually can be performed or Skyline or from another many different processing tools. And then after that they said, okay, then here's the part. Here's a statistic part, group comparison, right? They just say very simply, I did the group comparison or statistic. However, I just bring the same figure a little bit modified. One of the paper from Nature by League in Johns Hopkins, probably people already saw from the intro R. They said from this data set there are so many different steps we perform until we got the p-value. So here raw data is not raw file. So raw data for me is quantified peak data. So we got the quantified peak data. And then from here to the end of the p-value, we have so many multiple steps we are doing. Even just simple cleaning, simple filtering. Actually, the simple filtering also can affect your final result. So, for example, from raw data, we made a data cleaning. So data cleaning means you have to look at the data if there are any error when they generate the quantified p or there are any kind of issue. Like so many steps, we have to check it. And then after that, like you just make some nicer format and then find the potential statistical model, and then finally make some statistic, and then they just need to report the p-value. So quite many steps is involved in. So if I go back to the IPRG data, what the Olga showed this morning, when I evaluate the multiple result, we can see some grouping for their performance. Some group is always better than the other groups and so on. Probably they are doing not for statistics, they are doing some different method of the data cleaning. And if they start to really same data set, probably whatever they use some different statistic, maybe they can get some similar result. So for this many steps, our goal is want to make everything just available in MSstats, of course, any different processing tool, which means we don't need to worry about any kind of the data filtering issue, like any other correct or any other reproducible the cleaning things we have to do. So just we want to do everything within the MSstats for multiple steps. Just one. So my goal is for today, we want to go over from beginning to the end with the multiple data set, and then we want to compare how actually the difference by different processing tools. Actually, my goal is not to show which one is the best tool for you. It can be different. This is only for this specific IPRG data, but we can address for if we have this kind of issue, how it can affect it for if you use the MSstats and so on. So let's just start to our section. So just summary. I just put this one just in case for reference if you want to compare later. So we have 6 spike-in proteins here, and then there are 4 different conditions, and then depending on the condition, we have 3 replicate. And then here, for example, this protein ID actually spike in this difference amount. So for example, for this specific protein, they should be 7.5 changes. and so on. So I hope this can be reference for later. So then let's start to our practice. So let's open the R. I hope that everyone knows R Studio and R, and then succeeds to install the MSstats. So library MSstats. People who succeed to load the MSstats, please put the blue one. If you have an issue, please put the red one, please. So then let's see. So so this is the folder what I unzip. So you should have the 4 different folder. Do you have this? And then each the folder I have a data over here. So let's just start with the skyline folder. So I will go to. So here I will try to find where's my folder. So please find your folder too. So mine has under the desktop, and then here, and then open, and then I will set up this as a working directory. So here click more, and then I will click the set up the working directory here. So now I'm ready to start it. Okay? Everyone get it? Sorry? So here, you're more. Here. Then let's start to read the skyline output. So I will use the read CSV file. So I will say row skyline. Oh, okay, I will start the comment. Okay, this is the analysis for skyline output. Okay, so this is a comment. It doesn't matter. Just I made a note. And row the skyline and read the CSV file, which call under data skyline here, and then this CSV file. So name should be ABRF 2015 underbar skyline report.csv. People who already have this file, please just check the data. Like for example, how many proteins it includes, how it annotated by run condition, biological replicate, what kind of the fragment information it has. Just look around how the data look like. Okay, so then let's check how the data look like first. So I will check what kind of the column this skyline has it. So just check ahead of this. So here we go. So skyline and the MSstat work very closely. So we already recast then, make a MSstat report format in the skyline. So how we can report the skyline, if you are interested in, I will show you the next the sections. So actually, so report from the skyline already include the required column information for MSstat with some extra information. So not completely ready to use the MSstat. So we still need some extra filtering stage, but still the rows, the skyline report include the protein name column, and then you can notice here they report decoyed protein name too here, and then peptide sequence and peptide modified sequence, precursor charge, and so on, and label information, and here's a condition. But now you can see now condition information is empty. And then here biological replication, that one is empty. And then file name is basically MS run information. And then here they have an area, which is a peak area, what the skyline report. And then they also have several different information, standard type, and then this is truncated, and then annotation Q value, and so on. So this is just skyline. So we're gonna repeat again with the different processing tool. They report quite different format and different information, but let's focus on here the skyline output. So first, always whenever I just read the data, I just check the several information, whether it actually is correct or not. Even sometimes a very small typo make something different and then make an error. So usually I just check the data like this. So for example, I will first check how many unique protein ID information it has, row skyline, and protein name. It means I want to get the length of means how many unique row skylines proteins informations. Then it shows there are 3,097 proteins, right? And then here's the also unique things. The skyline for DDA cases, skyline report several isotopic peak for peptide charge. So I want to check it. So row skyline and then fragment information. It shows 3 isotopic peaks information show. This is quite unique for skyline too. So we are gonna handle this one in the MSstat too. This is the data. Yeah.
And this is also the data.
No, they don't need it. If they have needed it, just this too. Yeah. And then also what usually I also check is I have a correct MS run information, especially how many. Like sometimes just the underbar or hyphen makes a difference. So here I check the file name. It says 12. This is what I expected. There are 12 unique information. And also I can check row skyline truncated. This is also very unique information in skyline. They have a true peak and false peak. So true means it actually skyline report this peak area is truncated, which means we cannot trust it. So truncate means if you have a peak like this shape, so not actually we calculate the whole area. some point we actually calculate just partial of the peak, which is incorrect. So that is mark it. So we are going to handle this one too later. And then we can actually check how many truncated peak here. Truncated equal true. So here's a tip. So true is a little bit different. Like T is capital, other one is lower. So this should be the just character, not logical value. So it shows there are 829 truncated peaks in this data. Okay, so this is just typically I just briefly just check the data before I start anything. Everyone okay so far? Right. So I reported this, and then if you remember, I found the condition and biological information is empty, which is very critical for statistical analysis. So let's read our annotation file. This is the annotation. So if I open it, okay, so it's better to open here. This is the annotation file. And then this is not automatically generated. Basically, the user or you have to make it because any tool doesn't know about your experiment itself. So this is the minimum requirement. So here's the run information or file name information. And then you have to assign it. This specific run came from which condition, and then which biological replicate. This is what you made it, because the tool doesn't care of this sample came from which condition or not. Okay. This is very. I thought this is quite simple. But I realized 99% people made a mistake this part. And then if you made a mistake, actually the result is different. So I'll decide to discuss this a little bit more than before. So let's see this one. So we can distinguish two different cases, time courses or just case control. So case control means we have two different groups, but actually the biological or subject or individual is not overlapping between two. So for example, cancer versus a healthy group. Cancer subject always have a cancer, and then healthy subject doesn't have any cancer. So they are completely two different cases. So for example here, I assigned that this is a healthy group, and let's see we have three biological replicate, means 3 individual for each group. So healthy group we have individual 1, 2, 3, and then cancer group we have another individual 4, 5, 6, right? So this 3 and this 3 completely different biological replicate, which means you have to assign the different ID for biological replicate columns. Is it okay? So, for example, this case, condition should be healthy, and then biological replicate is 1, right? Second one is condition healthy, biological replicate 2, right? And then here, condition cancer, and then biological replicate 4, and so on, right? And then run ID. Actually, I just put the different 6 number because I just want to say this should be the randomized, right? We don't need to run 1, 2, 3, 4, 5, 6. Just based on any your order, you can make a different run ID. So far this is correct, right? If you have a technical replicate for each case, which means you have a sample but just multiply measured, right? Then we start from here and here, but measure 3 times for each cases, right? Which means this is this, just repeat it. So condition and biological replicate the healthy and biological replicate 1, healthy biological replicate 1, healthy and biological replicate 1. However, run ID should be different, right? This is how the MSstat recognizes this line. Condition and biological replicate information same, a multiple ID, we recognize this is the technical replicate. Okay? And then same thing. Here is the same, and then only run is different. So I can see, if this individual and this individual are completely different, and then you have the different ID. And then this is the time course. So time course means we have the same individual, but different time point we measure several times, right? Which means for individual 1, we have an individual biological replicate 1, but we have a condition can be different. Time point 1, time point 2, time point 3, and so on. Right? So you can see this one and the previous case is different. Previous case, this one actually the condition is the same, but here from same individual we have a different condition informations. Okay? Okay. Blue, okay, red, not. Okay? So this is the key one. The reason why I ask, people is quite confused about biological replicate, technical replicate. So they actually assign the biological replicate 1 to 3, 1 to 3, 1 to 3. If any, we have any same biological replicate information same, we actually make a link in MSstat or any kind of experiment design. So that is the things. This is a time course. However, the paired design, recall, this is also same, not the time point, just change the time point as different tissues. So for example, from same individual, if you take the sample from different organ, right? So actually we came from the same individual, but actually the tissue is different. Like for example, one is from healthy tissue, one is from the other cancer tissue, and so on. Which means we have a same individual, but we have a different condition. This is actually same as the time course design. Okay? So, yes. It's the same way, yes. So, that is the key part. So let's go back to our design. So we have a 1, 2, 3, 4 different conditions. And then I said we have a 3 replicate, right? Per each condition. So here, if I sort it, so here I said this 3 run from sample 1, actually from the condition 1, and then A, B, C. Like A, B, C, just like they are just 3 replicate. Okay? So here I said the same biological replicate, and then they recognize there is 3 different technical replicate. And then here condition 2, and then here so we just repeat 3 times, and then for condition 3, and here I just repeat the 3 times. Common mistake is people assign here A, B, C, A, B, C, A, B, C, A, B, C. Because they just say, for this specific condition, I have 3 different things. That's what they want. However, if you say 1, 2, 3, 1, 2, 3, 1, 2, 3, we recognize there are 1 specific biological replicate, and then we measure the 4 different conditions. And then all the degree of freedom will be different, and then result will be different. Okay? Clear? Yes. So, then let's read this annotation one. So I said annotate skyline, read CSV under data skyline. ABRF skyline annotation CSV. It's not here. Did I make any mistake? Okay, it's a space. So now I have an annotation skyline file here. Okay, so two files ready. The one of the front processing tools and then annotation files. Then after you read these two, we are gonna start with this one. So raw file, raw data is the quantification file from Skyline, and then here is the step. So this step, we usually call we call the converter function. Converter function means output from processing tool to MSstat required format. And then between these two, we actually doing a lot of the clearing stage. So we actually now 7 different converter: Skyline, MaxQuant, OpenMS, Progenesis, Proteome Discoverer, Spectronaut, OpenSWAS, what else? DI Empire, so like 8, okay. DI Empire. So today, but we are going to focus on DDA case. So what actually this function is doing? So here for Skyline 2 MSstat format function we use. If you use MaxQuant 2 MSstat format and so on. So what we are doing is first rearrange the column, simple, and then remove the decoyed protein or IRT proteins, and then remove the shared peptide. We have an option if you want to keep it, just you can just keep it, and then replace the NA to truncated peaks. If they say truncated peak, we are not trust this one. We just place this one NA, just randomly missing value, not because of the lower abundance, just random missing. DDA case, if they have an isotopic peak, we just sum up these 3 peak intensity. For DIA case, we filtered some features by their provided Q value. And then here's also quite a key step. So not many tools doing this, but we are consistently doing this step for all different processing tools. So if they have any feature have less than 3 measurement, we just completely remove these features. If they have only 2 DAFR features, there are a lot of the issue, because when we impute algorithm and so on, there are issues for refitting the model. So and even though we can do this too small value, so we just completely remove this one. And then also if they completely missing anything, we just also remove it. And then another thing is there's an option we can remove any protein which have only 1 feature. So 1 feature, okay, we can do this. However, how much it can be reproducible? So, but there's an option you can do with this one or without these functions. And then add our annotation file to our quantification function. So let's go back to our R Studio. So with these 2 functions, what I'm going to do is I will make an input Skyline data, and then Skyline to MSstat format. There's a capital lower letter is mixed, so I recommend just choose the recommendation, and then put the raw Skyline, and then annotation should be our annotate Skyline, And then I want to remove proteins with one feature equal true. And then I run it. And then they start to show something here. People who type this and press run, and then you got the data input skyline. Please put the blue one. If you have an issue, please put the red one, please. Most of you have an input skyline. So if you see here, this is our original raw skyline file. This much measurement we have. Now after refiltering out and some processing, now we have a quite smaller number of the measurement we have. The major one is because we removed, summarized the isotopic peak. So it should be almost like 1/3, I guess, because we summarized the 3 isotopic peak, 1 value, some of this, and so on. So that is things, and then any extra filtering we applied as well. Okay? Then, yes? If skyline get the same, if you got this and same,
that's the row, that's the column, that's the row, the 3, 9, 8, 6, 8.
this is row.
Yeah, we are at 10
You should get the same number.
I got it.
Different number? Okay, then I will you too. How much do you have?
We have 407.
Okay.
That's what I have.
You too? How many people have this number? How many people have a different number? Okay. I will try to find the region and then I will be back this afternoon.
So my MSstats was the version was 3.10.
Okay. Could you check what version of MS that you have? Could you check what version MS that you have? So how you can check is here the package, and then here you can search here MSstat. Okay, 3.10.6. Okay, 3.10.6. Yeah, have a different one. I see. Got it.
Do we need to update?
It should because okay, here's the issue. So last week and this week the bioconductor have some transition stage. So some computer have this one, some computer have this one. So if you're early, yeah. So yes. So this is what I installed yesterday. So if you try one more time, maybe it will be updated. Yeah. So okay. So before we finish, so this is a skyline, and then let's check how the filtered data look like. So input, had input. So now you see that there are different columns. So now we have a protein name, peptide sequence, blah blah blah. Now we have a condition information field, and then biological replicate information also field, and then run information, and then intensity, and then so on. So now we remove the sum of the columns. So before I move on, this is I always check at the end. First one is unique. I just check the unique information of run condition biological replicate to double check our annotation is correctly inputted or not. No?
No.
So first I check how many rows we have. 1, 2, 3, 4, 5, 6, 7, 8, 12. This is correct, what I expected, and then also double check it. Sometimes condition or biological information is empty or NA or incorrectly inputted. So 50% of what I got from user, I have an error message, is based on these annotations. So usually I just fix this one. Okay, here's the error, and then most likely we can fix it. So this is kind of the important part. And then about the missing value, let's check a little bit. So there are two missing value we can consider, so NA and 0. So for Skyline, they reported two missing value, NA and 0 both. So let's count how many NA we have. Let's sum is any NA value in input Skyline intensity column. So from input Skyline intensity column, how many NAs are, right? And then it says there are 184 NA values. And then next to what also check is if not NA line intensity and input Skyline intensity value is less than 1. So sometimes it can report 0.003 or something like this. I also try to, this one is also 0. And then I run it. Here it said there are more than 2,000. Intensity is less than 1. So Skyline case, we are imputed this value, and then we will just leave this NA value. It's just a random missing one. And then finally, I will check. So just double check again how many protein information are left here. Now we have 3,018 proteins. Before we have 3,097 proteins, but around 80 proteins is removed. Okay? And then I want to save this intermediate result in our folder. Save our input Skyline add data Skyline and input the Skyline R data files. Then this filtered data will be saved under our folders. people succeed so far, please put the blue one. If you have a difficulty, please put the red one. People who already succeed, please check the this file, this function, what kind of options are available in this case. So if I just want to double check what kind of option available from this function, here we go. You can change some of the filtering strategy over here. Yes.
Is removing the decoys an argument or part of the function?
This is default.
Any other keywords?
So here, a decoy, there are two ways I can find a decoy. There are standard type column, it shows the decoy, or from protein ID, we can find the decoy, blah, blah, blah. If I can find any decoy, we can remove them.
But does that, you don't have to, that's just part of the function?
Yes, yeah, 13.1.
Can
So,
I
yeah.
add other, like, keywords and do the same thing?
So
Like,
far,
if you run
no.
against, like, a contaminant database or something, can you pull those out?
So, for max count output, they have also information of a contaminate or like something like this. We can just filter out that information. So far, Skyline, I don't think they provide this information. So far, no. So if you want, but however, if you want to remove the protein con dash or something like that, actually you have to do outside of the description. Yeah. So far, so good. So for next section, we will start with this input skyline 1. However, if you want to do something more, I will recommend you to make input the required input format for MSstats from OpenMS output, especially who actually take the OpenMS module last week. So OpenMS, I know there are like LFQ analysis part. You are practicing how actually you can make a pipeline for MSstat analysis. But here, actually, we take the intermediate data, and then here's a practice of how you can manually do this. So this is like the optional take-home for lunch. But if you succeed so far, I will start with the input skyline from the afternoon sections. Okay? So have good lunch, and then let's see at the 1:30.